Hi, this is the second of the two videos on research designs that I'm producing here, where the first one took departure in the Research Design 2001 book chapter, identifies the overall archetypical research designs you can engage in and their main characteristics, main strengths and weaknesses. We're diving one step deeper here, taking departure in an editorial written for researchers as an audience. It's on a more advanced level, identifying some challenges and pitfalls that a research design can have and that we want to avoid if we really want to trust the results. So again, this is written for researchers. It's also written for people that usually have quite a bit of time when they are engaging in their research. That's why we can have these sort of stronger expectations for how well developed the research is supposed to be. So we have some key challenges that I want to go through here just quickly, and again using the video games, the violent video games and aggressive behavior as an example. But I also want to emphasize the quote down here, as it says here, there are no hard and fast rules to apply. Matching research design to research questions is as much art as science. And there are often external factors that constrain researchers' ability to carry out the perfect research design. But still, we want to be able to pay attention to what pitfalls might make us trust results less, might make us more skeptical. That's what I want to go through here. Okay, we've already covered this actually in the other video, and it's a typical challenge. People have cross-sectional data but still want to make a change argument. You have data on how much young kids play violent video games and how much aggressive behavior they engage in. And you might be able to show variation that says that kids that play more violent video games also engage in more aggressive behavior. Then the argument you want to make might be playing more violent video games leads to more aggressive behavior. But if you only have one snapshot, you don't know anything about change. You don't know if it's actually aggressive behavior that causes you to play more violent video games. You don't know if a third factor is important. You can't say anything about change except cross-sectionally speaking in your data set, which doesn't allow causality. So if there is a change argument in a paper, it has to have some kind of longitudinal data, some kind of experimental design, or some fancy econometric methods that we haven't covered here in the Bachelor to allow that kind of analysis. That's a key thing to pay attention to. Is there a argument about something improving something, changing something, causing something, leading to something? These are all change arguments. Okay, second one. What is the sample that a researcher has relied upon? Is it an appropriate sample? Let's say you want to study the decisions that a CEO or top manager makes. Is it then relevant to engage in a lab experiment, for instance, with students? Well, maybe MBA students that come from practice are more interesting. Or if you want to do a study on, again, violent video games, and you want to see how being exposed to violent video games might make you think or behave differently. If you do this study on students, well, it doesn't really capture how young kids might react here. So, is your sample appropriate? And in medicine, the typical challenge is that either you have studies done on mice and cancer, small mice in plural, or you have study on healthy young males, and so you actually don't know how older people or young kids or pregnant women react to a certain kind of drug. So it's always paying attention to, is the sample of people that you study actually appropriate for whatever you're interested in. Another key one that we've mentioned before, selecting on a dependent variable. As highlighted here, if you're interested in how entrepreneurs become successful, well, if you only look at successful entrepreneurs, you might not realize that whatever these successful entrepreneurs do might be the same thing that the unsuccessful entrepreneur did. Violent video game example. What if we only looked at kids displaying aggressive behavior? This is interesting for figuring out that what they do and how they do it, the same with entrepreneurs. I'm not saying it's not interesting, but we can't say, well, look, this is the kind of look at all these kids that are aggressive in their behavior. They also play these video games. Hence, there must be some kind of link here, right? I mean, they all play these violent video games. Surely there is something to it. We don't know if all sorts of non-aggressive kids also play these violent video games if we've selected on the dependent variable, if we only study those that engage in the outcome, that showcase the outcome that we're interested in. Broad challenge here, a careful construct creation. How have you measured whatever you're interested in? So if you think back to first semester, NORIA organizational behavior, when they wanted to measure motivation, they inquired into commitment, satisfaction, likelihood to change job, etc. They really tried to very carefully capture the phenomena they were interested in. So, and the same with the kids example in the violent video games. If you remember, there was either a focus on just asking kids if they think they play violent video games and if they think they engage in aggressive behavior, or you could actually ask their caregivers about what they think about their aggressiveness in order to get a stronger, better measurement of whatever we're interested in. So how well crafted is the construct that you have here? How well does it actually match whatever you're interested in measuring, and does it align with the theory that you want to put in place here? Related to that, also relating to the kids example I gave before, is something we call common method variance, or common method bias. And it's when you want to explain something, use some independent, some explanatory variables to explain something else, the dependent variable, but you've gotten your data from the same source. So the example I've given here is, let's say you're interested in management styles, and you ask the employees about how motivated they are and how great they think their leader is. If they are sort of both under and over reporting leadership effectiveness, and if it's sort of unrelated to the motivation, then that's fine. But if you only have information from the employees, you don't quite know this. So maybe a more sort of straightforward example is the video kits. If you ask the kids about what constitutes a violent video game and how much they play, and from the same kids also try to get them to assess their own aggressive behavior, well, it might be that more aggressive kids simply have a different perception of what a violent video game is. So you're actually not getting an unbiased take. That's why we call this common methods bias. That if you use the same approach, the same source for these different kinds of information, you might get a systematic bias. It might be the case that some very unmotivated employees have a particular perception on their leadership style. So we're actually not getting an assessment of the leader's management style. We're actually just getting an extension of what employees, how motivated employees think they are. So try to pay attention to, so to put it more simply, try to pay attention to where is the data coming from. Has one been trying to make sure that whatever you're explaining and whatever you use to explain something else, that they've really tried to distinguish different sources in order to avoid these systematic biases that I mentioned with the video kits, for example. In the Brender 2018 exam question example, we had assessment of management styles, both from the managers themselves. We had it from employees. We measured employee productivity both by asking managers. We had some objective, more or less, data from the company. We're really trying to measure things as careful as possible based on information from different sources. Another aspect emphasized by this AMJ editorial is what we call omitted variable bias. What if we wanted to explain the violent video games and it turns out that engaging in aggressive behavior is actually just due to the violent upbringing or due to whatever genetic factors that shape behavior, whatever it could be. We could be in a situation where we've trying to explain something, but we haven't collected key variable that in the end is going to be critical. What if O'Reilly is trying to explain something in his bionicle study about meaningful and non-meaningful situations, but maybe different age groups behave completely differently? This would then be an important factor to add to explaining what is going on here. Also had the university example before. We might want to find out if a university has a positive impact on their students' future income compared to other universities or no universities. But if you don't take the pre-university ability into account, whether it's personality, your ambition, or intelligence, then you're omitting a very relevant variable, and you risk that whatever data you have is leading you in the wrong direction. So there's some key information that is not seen to have been collected. Okay. Just one more comment here on this Research Design 2011 text. The point I'm trying to make here, in that text, they make a distinction between descriptive and explanatory research designs. It's very similar to descriptive in Hambrick and explanatory expectation in the Sutton Stahl article, just to make that link. And they also talk about probabilistic versus deterministic theories. Again, as I've talked about in physics, we can expect deterministic theories that always explain, can explain what is going on, like the law of gravity. While in social science, we just have to accept that it's always going to be probabilistic theory. Likelihood. We can, on average, explain more based on these variables than without them. Just to highlight the point here. And then we have this overview, very rough rules of thumb, but something to pay attention to and keep in mind that experiments have these strengths and weaknesses, longitudinal data have these strengths and weaknesses, etc. But again, these are sort of rough overall rules of thumb, and there can be all sorts of exceptions in all sorts of specific cases.